Yeah. See, you have to get the triangle right.
Yeah.
So if the swimmer is actually swimming like this with respect to the ground. So if a person who is standing on the ground, it will look as if he's going straight. So that is velocity of the swimmer with respect to the ground. So that is velocity of the swimmer. Okay. But he should head in this direction so that he actually swims like this. So this is the triangle, the one here on the right side. This one. Velocity of swimmer is vertically up. That's with respect to the ground or the bank. And velocity of the river is towards left. Okay, so if you add these two, I'll get this one, which is making 150 degrees with the horizontal or the x-axis. So if you get this triangle right, then you'll get the answer right. So this VSR with respect to the river. So that is 2. So hypotenuse is 2. Okay, so velocity of swimmer should be 2 sine 30, which is half. Sorry, which is 1 kilometers per hour. And to travel distance 1 kilometer, it will take 1 hour. So this is important thing to realize that you have to get the triangle right. Another thing is the swimmer is actually taking this path. So that is the path seen by the person who is standing here on the bank or the ground. And whatever he sees is the velocity of the swimmer with respect to the ground. So by default, it is ground. So just I have not put G here. So VS means velocity of the swimmer with respect to the ground or the bank. Is it clear?
Yes, sir.
Okay.
Yeah, that's all the doubtful questions. Remaining is on the school.
From this one. Tangential acceleration. There is only one acceleration, which is the vertical. Okay. So the topmost point, the tangential acceleration is 0. So the initial point, so just a geometry question. So this is a parabolic path. There's only one acceleration, which is the Earth's gravity, which is downwards. Okay, so the topmost point, the tangential acceleration is 0 at the topmost point. But here, this is the tangent, and this is G. Okay, so I have to take the component of G in this direction. So G cos will be negative. Okay. Negative here. Here in this case, G is like this and it's coming down like this. And this is how to take this component. So here it is positive. So negative, 0, positive. So acceleration is increasing from negative, 0, and positive. This one, option 1. Check the answer.
Yes, it is.
Understood? No, I just taken 3 simple points.
Acceleration already goes zero, to be honest.
So there's only
Everything will
one.
stay positive.
What?
Yeah, the acceleration on projector is negative, and when going in the downward direction is positive.
You will take the tangential component.
Yeah.
It's always vertical acceleration because of Earth's gravity. Okay, there is acceleration nothing but force. There is only one force, which is gravity force. So it's vertically downwards. So the direction of the tangent is changing. So you have to take so the topmost point is easy to figure out because tangent is horizontal. So it is 0. At the bottommost point, it's opposing the tangential motion. So on the right side is supporting the tangential motion. So on the right side is positive, left side is negative. The force is pulling it down. Right side, the force is helping the motion. So that's why it's positive.
That was it, sir. That's all the doubtful questions. Remaining I ask.
Okay, so today is the second class or first class on laws of motion.
First class.
What did they teach?
Inertia and Newton's first law.
Only that much. How much time did
Newton's first law and second law. I'm sorry.
any problems they solved?
No, they haven't started it. They haven't started it. And start the exam again.
Okay. Uh, Translation motion, rotational motion, two types of motion. Momentum they have discussed. So what is momentum?
Yeah.
What is it?
For difference in force by time. Or F is
Difference in?
equal to
No, momentum is
uh,
just mass into velocity.
the P vector is equal to M vector into V. M into V vector.
Okay. So if you have to increase the momentum, either the mass has to be more or the velocity has to be more.
I saw in relation that force is equal to change in momentum by change in time.
Yeah. That is second law.
Yeah. So if we integrate both sides, we can get that more force is momentum is equal to force into T. That's also one formula.
Yeah, yeah. So give an example of a contact force and a field force. Field force is basically non-contact force. What's an example of contact force?
An
Example.
object falling on a table, contact force.
That is during the impact, no? What is a non-contact
Oh,
force?
okay, pushing and pulling something.
Non-contact force, field force.
Non-contact forces, air resistance,
No, air
and
resistance is a,
acceleration due to gravity.
yeah, because there is no connection between Earth and the object, but still the force is there. Like between Earth and the Moon, there is no contact between Earth and the Moon, but the force is there. Okay, between Sun and the Earth. So that is field force or non-contact force. Air resistance is a contact force because of friction between the air molecule and the solid object. Okay, even friction is a contact force. A box sliding on a surface. So it's a contact between two surfaces. So friction force is a contact force. Free body diagram did we discuss? Free body diagram.
Yeah, free body diagram. That's one thing.
What is free body diagram?
A body in free fall, like with R resistance, that and all. Sir, 1 minute.
Yeah. For example, let me consider this simple pendulum.
Yeah. Sir,
So, for example, this is simple pendulum. So this mass is in contact with the string, right? So I remove the string and replace the string by a force, tension force. Similarly, gravity is there, Earth's. So I remove this Earth and the gravity and replace by a force, mg. So here the bob has become free, but I include the effect of the other bodies like string by a force and the Earth's gravity by a force mg. So this here the body is free, but I have to get the same effect. To do that, I have to apply the corresponding forces. So this is free body diagram, which shows the forces acting on the body. Is it clear? Your mic is off.
it is clear, sir.
Uh, So to make the body free, but you have to produce the same effect. So whatever is there attaching the body, replace them by the forces. So how much mark did you get?
Not yet said. They didn't say it.
Today is Tuesday, you know.
Yes.
So spring, this one, it's a relaxed spring. Okay, in this case, there will be force in the spring will be zero. When you will disturb the spring from the relaxed position, force will get developed. So I can disturb this relaxed spring by two ways. One is by compressing it. Okay, another is by stretching it. Both the cases, once I stretch it, there will be a force towards the relaxed position or the normal position. So it'll be the towards left. So when I compress the spring, there'll be a force acting towards right to bring it back to the relaxed position. Okay, the interesting thing is if I stretch the thing by an amount x and compress this thing by an amount x, the amount of force is same, the value, which is kx, but the direction is opposite. The while compressing the force is towards right, while stretching the force is towards left. And Hooke's law states, suppose I apply a force F and the compression is say X. If I double the force, then the compression will double. If I increase the force 1.5 times, the compression will increase 1.5 times. If I reduce the force to 0.5, then the compression will reduce by 0.5. So there's a linear relationship between the amount of force applied and the compression. Same for elongation. If I double the force, the amount of extension will double. So it's a linear relation. So this straight line relation between the force, which is the input, and the output is the extension or elongation or compression. It will be extension if the force is a pulling force. It will be
Yeah.
computed if the force is a pushing force. So the straight line is the Hooke's law. F is proportional to x and that F equal to k into x. It is minus kx because then minus sign indicates the direction of the force is towards the relaxed position. Here, while compression x is negative, but force is positive towards right. While elongation the x is positive, but the force is negative.
Yeah.
So equilibrium means the thing is not accelerating. That means the net force is zero.
Yeah.
And force is a vector, so the vector sum of the forces is zero. So this can be split into components along x-axis, y-axis, and z-axis because in general it's a 3D force. So it can have three components, x, y, and z. So all the components should become zero if it is an equilibrium. So if it's an equilibrium, means acceleration is zero, but it can't move with a uniform velocity. Even if it's moving at say 2 meters per second throughout, then the net force is zero. So we have three forces just pulling like this. If the net force is 0, then you have the relation F1 divided by the sine of the angle opposite that force, and F2 by sine of angle opposite that force, and F3 by sine of angle opposite. These three are equal. This is sine rule, which is called Lang's theorem. This is for three forces, not for other cases. Because sine rule is for triangle. If we redraw this figure, it will become like this. So then it's just the sine rule, F1 by opposite angle. Sine of opposite angle is sine. I'm going to try this question.
Tension,
You have to find the tension in both the strings. Straightforward question.
Yeah, figure 1 I think is 5 by root 3 tension is because it's just force into the u cos theta. Sir, force into cos theta.
You have to find both the tension, TA and TB, T1 and
Oh,
T2. It's not a single string, no?
oh, okay, as connected by 2.
So the
So
tension
like you have,
is different.
so like we have, yeah. So we have to take the high. It's 90 for a second one.
You have two
Tension in the
equations
first
to
string is 5 root 3, and in the second one it's
you have to find TA and TB, both
TA plus TV are like
individually.
okay. Tension in the string OB I found. But in the string OA,
How many unknowns are there? T1 and
yes
T2.
sir.
How many unknowns? Two unknowns, T1 and T2. How many equations? Two equations. One is the X equation, one is the Y equation. So two unknowns, two equations.
Yeah. Weight found. I found the weight. I'm using it. Okay, it's just trigonometry. It's just root 3, root 3, root 2. Tension 1 is 20. No, tension 1 is 10 and tension 2 is 20. Is it right, sir?
That is the figure 1, right?
Yeah, figure 1.
Yeah, figure 1 here is correct. What about figure 2?
Figure 2 I'm doing.
Same thing.
Yeah.
Two equations, two unknowns.
Second one theta value we have to find out.
So theta is also unknown, but this tension has to be minimum. So
Second one is also 60 degrees. Same. T1 is like
This is the expression for T1.
yeah. Theta I got 60, but I use some different method. Sir,
Yeah, yeah. So so these are the two equations. Horizontal direction, okay. Vertical direction, this is the one. And solving these two, I'll get T1 as this one. So this is a variable in theta. So for this to be minimum, the denominator has to be maximum. So for this to be maximum, this can be written as root 3 by 2 and then half. This is standard way of maximizing this one. So this can be rewritten as root 3 by 2 sine theta plus half cos theta equal to 1. So this is nothing but sine, or I can write as cos 30, right? And this is sine 30. So this thing will become sine theta plus 30. And the maximum value of this thing is 1. That will happen when theta is 60 degrees. Because sine is maximum when angle is 90 degrees. So theta is 60. This is one way of getting the theta for maximum value of this expression. It's actually a standard method of solving. Sine plus cos equal to some number. Bring that number down. And this first thing, write this angle. Okay, so there will be sine this one. So in general, if you have an expression a cos theta plus b sine theta equal to c, find so this expression f of theta, find f max. Okay, so the standard way of doing this, bring the c down. So a by c cos theta plus b by c sine theta equal to 1. So this nothing but
equal to 1.
f of theta by c. So when f of theta is maximum, suppose c is positive. Okay, so this is also maximum. Because I just f of theta by c, no? So then the maximum value of this one is 1. So that will give me exact value of theta for which this thing is 1. So this thing can be written as, for this you have to construct a triangle A here, B here, and then C here. So let this angle be alpha. Okay, so A by C you can write as sine alpha. And this is cos alpha. So this will become sine alpha plus theta equal to 1. So that means alpha plus theta is 90 degrees. Okay, so if one of the angle is say 60 or 30, other one is 60. Understood? The mic is off.
Yes, sir. Understood. Yeah.
Get the answer. Two boxes A and B of masses M and capital M suspended. Things in equilibrium is also at rest. Net force is 0. You can think of some simple cases. Suppose A is very heavy, 100 kg, and B is say 1 kg. Then what will happen? A will come down, right? Your mic is off. Your mic is off.
Yeah. Yeah.
Assume
Yeah.
the one, say, special case or extreme case where A is heavy, say 100 kg, and B is 1 kg. In this case, it won't be inequilibrium because A will come down and B will go up. Suppose you assume the opposite, B is very heavy, say 100 kg, and A is 1 kg, then B will come down. But these masses are then they are at rest. Okay, so you have to find the relation between the two masses. That is the question. Get the answer.
Yes.
What is the answer?
They have given to express the m in the terms of small m.
Yeah, yeah. Find capital M equal to some function of M.
Yeah.
What is that function?
Force.
Answer is
Force.
2M. 2M.
Yeah. To m.
Simple question, no? Free body diagram of A. Tension up is balanced by mg. Okay. And the free body diagram of the pulley, 2T. The T is in because the pulley is smooth and it's massless. So tension will be same. And the downward force is F. And this force is the force acting on this B. So F equal to M into G. So this F is 2T. So 2T is supporting mg and T is supporting M. So M can be more and M is double the small m. Clear?
Yes, sir.
Similar question. Two masses M and M. So you have to find the relations other is at rest. Try this one.
this they have given express m in terms of n.
Answer should depend on theta also.
They have given it's supposed to be mg cos theta and mg sin theta. We
Tension
can
you can
assume
get
that.
it to mass B.
Yeah.
B is capital M. So tension is nothing but capital M into G. So same tension is here. And the component
So
of
that means
mg down is, so T should be balanced by mg sin theta.
yeah. So if it is balanced by mg sin theta, then the force can be equalized and yeah, then m is equal to m sin theta
Hmm. So check for
is it the
extreme
answer?
case. What is the extreme case here? T in terms of theta. Suppose theta is a variable.
A is more heavier than B or B is more heavier than A.
No, if it
Or
is
theta
what?
is an extreme angle like 90 degrees.
So if it is 90 degrees, what should be the relation between A and B? Both should be equal, right?
Yeah, if A and B are the same mass, then both of them should be equal.
No. If theta is 90, both should be equal.
Yeah.
What about theta is 0 degrees?
So, like A should be heavier than B.
Much heavier, right? Hmm. Because when theta is 0, capital M is 0. What is capital M? This is the B block.
Capital M is B. So A is heavier than B.
So one thing you can do, you can put, instead of 0, you can put delta. Delta is a small angle, it's almost flat. So sine delta, it is 0. So even if M is 100 kg, this the round mass should be almost 0. So when it is horizontal, since the thing is frictionless, okay, even a small mass here, B, will pull it down. Okay.
R resistance and like one tension from the string, force from the string, then backward force from that spring.
Yeah. So this is the free body diagram. Tension is there at an angle theta. Weight because of the gravity. There's a normal direction because there is a contact here. And the spring force. Okay. So you can see the unknowns are T, theta, Kx, and also
And
normal
gravity.
direction. Okay. So you have to find the tension in terms of other variables. Theta is given in the question, so it's not a unknown.
Minimum tension is
X is a unknown.
T has to be equal to mg into kx. No, like n into kx. So hence we can get x is equal to mg cos theta divided by k.
So
Is it
tomorrow
right?
you have physical class, no?
Yeah.
So next class is on today is what?
Thursday.
Thursday. Okay. After the
Saturday
Friday,
exam, sir.
which Saturday? This Saturday.
This Saturday.
What exam?
720 marks. NEET.
It's usually on Monday, right?
Yeah. They due to homesick holidays, they like kept it early.
Monday school is there.
Yeah.
Okay. And what is the portion?
Portion is Newton's first law, second law, third law, law of inertia, and the remaining the portion sheet I'll forward, sir.
Okay. This 2D motion is there.
Yes,
Motion in
there is.
motion in a plane. Entire chapter or half?
Yeah, motion in a plane full chapter, sir.
Okay. Fine.
Along with that, few of this. That was it, basically.
So how many marks are you expecting in physics?
Above 150.
No. This physics, this last test.
Last test. Yeah, above 150 only, sir. More or less.
Okay, just 1 minute is there. So you can try these questions. If you, this actually is shared with you. Yes. So you first try your, what are they called, the exercise book. After that, you can try these ones.
Will do.
Okay, then see you on Thursday.
Yeah, okay, sir.
Okay, then bye.
Yes, sir. I'll see you on Thursday.